I understand you want to learn programming and you're in a good way of doing that. However, there are many other people out there who already know programming, and using their results and using their help is actually a great way to get better results without you having to reinvent everything, particularly the wheel. And in order to do that, we need to get other people's work into our code. And the means to do that are objects and modules. So this is what we're going to talk about today. In the end, we are going to reach a state where we will have two nice greeter objects, one a plain one and the other one is the greater greeter, which gives you a very nice greeting. Let me show you how it happens. Hi, my name is Aaron, and in this video I'm going to talk to you about objects in Python. But first of all, let's declare what an object is. Let's kind of put this into spotlight so we can all agree and talk about the same thing. So, as you are probably aware by now, in Python we have variables and we have functions. And obviously what we typically do is call those functions, pass them variables. I usually use the example of a vending machine. So a function is like a vending machine. You put something in on top, something falls out in the bottom, that's your function. You typically store information in variables. Some come from the user with the input function, for example. Some come as a result of other functions, and then you put that into, again, a function. That's basically what your program does. And it doesn't matter if it's the controlling software of a nuclear power plant or just a calculator that you did for practice. All the programs that we write in Python pretty much do the same thing. But when you start doing this, after a while, you come to the realization that there is a connection, a link between your variables and your functions. Some functions tend to modify certain variables, or the result, the outcome of certain functions is always stored in the same variable. You somehow discover that these are connected, they have a logical link between them. And surprisingly enough, this discovery was made, kind of course everybody knew it, but kind of was put in a different light in the end of 90s. That was not that far away. We're not talking about, decades or something. At the end of the 90s, people said that, what if we took the variables and functions that usually go together and kind of wrap them into a wrapper and would call them an object. And that's all an object is, functions and variables packed into one package, okay? That's what we call an object. The hard part is that when they came to this realization, what they did was they realized that there is a description of what an object should look like, what variables it should have, and what functions it should be running on those variables. And there should be an actual memory area reserved where the variables are actually stored, okay? So imagine it like a bit of a meta thing when we describe what our data should look like and when we actually have the data. And the description of what our data should look like, our variables and functions, is called a class. And the memory area that we reserved for a specific set of variables is called an instance, okay? So we're gonna have classes and instances. And we are always going to write our classes and then reserve memory for them to create an instance. Let me show you. If this is not 100% clear now, don't worry at all. In practice, it will be very clear in a minute. Okay, so very obviously, classes are defined with the keyword class. I hope that is no surprise to you. And I will create a class which is called addition. And obviously, it immediately figured out what I want. I am using Claude Sonnet, which is a really nice tool. And I am using the Cursor IDE. In case you're not familiar, you can visit cursor.com, download it for free. This video is not sponsored, but Cursor is a great editor as well. Okay, so I am using that, and that's why I'm getting that help all the time. Just like I would after a function, I have to put a semicolon, and if you're even a little bit familiar with Python, you would probably guess that after a semicolon, I have to use the usual indentation to show what's inside the class and what's outside the class, okay? Inside the class, I can have variables and functions. Typically, we would have functions mostly in our class. Let me show you what let me show you how the whole thing begins, how we define what our class should look like. I'm just going to go ahead and declare a variable here. And since there is no variable declaration specifically in Python, we do that by actually giving them a value. So I'm just going to say A is 1, B is 2, okay? Disregard the rest, okay? And now I'm just going to define a function, which is actually add. That's perfectly finely guessed by the AI. And watch here, there is a very interesting thing. This function gets a parameter called self. Now this is the part where it gets a little bit tricky. This is the description of the class, okay? I am not reserving any memory here. I am just describing my class. However, when I am actually running the function, calling the function, I don't need an abstract description. I need specific variables. I need memory where my variables live, right? And I need an instance in order to be able to call that function. And that's exactly what this is. It's the instance, okay? The instance is always called self and is always the first parameter of a function inside a class. So now we can know that this method runs on an instance. And what it does is it returns self.a plus self plus b, self dot. That's a new notation we have not seen yet. That means I am not referring to just any variable. I want this variable that is inside my instance, which I called self, okay? So this is how you refer to an instance variable, just by putting the instance name and the dot before it, okay? All right, still don't worry if it's not 100% clear, because it will get clearer as we move on and on. Now, this class is called addition, and traditionally we use the camel case notation for class names, meaning that the first letter of every word is a capital. So I could have multiple words here. The point is all of them begins with a capital. And watch what the AI did here. It calls this class as if it was a function, right? Just calls it as if it was a function. And this is the way to create an instance, okay? And as soon as the instance is created, it becomes a variable. And that's one big secret of Python that is not obvious just by looking at it. Everything in Python is an object, or to be specific, an instance, okay? So everything in Python is an instance, and this is how the instances are created. And since it's a variable, I can reserve a memory cell for it and give it the name addition. So now I am putting my addition class instance into a variable called addition, okay? And capitalization matters, so this is not the same as this, because this is a variable which is traditionally with underscores, and this is with capital. It shows that it's a class, okay? And then I am calling a function. Now we know how to access things that are inside the package, inside the instance, with the dot notation. So addition.add will call this add function, okay? It's very logical, not very hard if you take a look at it. Obviously, we are referring to things that are on screen, so not very hard. And if I run it, surprisingly enough, I will find out that 1 plus 2 equals 3. Applause for Python for being able to do an addition. Not all functions inside a class are made the same. There is a very special function which is marked as special with 2 underscores. This is a convention in Python, okay? 2 underscores means this is something special that is not just for any use, it has a specific meaning. And that function is the init function. Yeah, it already knows what I'm trying to do. Brilliant. And the init function can take parameters just like any other function can, but the first parameter that it has to take, since it's a function that runs on an instance, is self, the instance variable, okay? And the thing is, the init is called whenever this function is called. So this is actually the function that gets called. And you can see that the AI is suggesting me to have values for A and B. But watch something very interesting. The same thing here, I just didn't outline it in my previous block. we are not passing self as a parameter, right? That happens automatically. So addition.add is absolutely equal to, let me just make it as a comment here, add, come on please, addition, yeah, okay, now it only takes the self parameter, so add addition, okay? If this was not a function inside my class, but it would be outside, and it would expect a self parameter, then I would pass addition as the instance variable as a parameter, right? This is what it actually does. This is how it works. So this is how you should think of instance variables and how the functions are called. Okay, let me show you something even more interesting. Now I can remove this from the class definition and just leave it with init, okay? So init has this special role that whatever variables you give a value to, they will just stick with that instance, okay? So it's basically the same thing, giving values to variables. Typically we choose this way because this way we are ensuring that these operations actually run when you are creating your new object. In certain cases this is important. Let's just say that for now this is the preferred way of having variables for a class. It's less readable, admittedly. However, it has its own benefits. Needless to say, we are still running just fine, and 1 plus 2 is still 3, so that's exactly the same thing. Okay, now watch this. I will take the AI suggestion, and look what it did. It is creating a new instance of this thing, okay? So the point of the whole object orientation stuff is I can create as many instances as I like, and each of them will have the same behavior, but different variables, okay? Let me create another example for you. Let me just run this so you can see that I'm not lying. Ha ha ha. Of course I'm not. Let me just create a class that will be called greeter, okay? That's my greeter class. I will learn to type one fine day. In my init, I will obviously take a name as parameter, store it, and watch that name is a parameter here, and I'm using self.name, creating a new variable in the instance, and I copy the value name to that, okay? And then here is the greet function, which says hello self.name, brilliant. And then I do a create, which is not John, it's not gonna be John, it's gonna be me, okay? And then very obviously it says hello Aaron, because that's the route of the parameter that we did, okay? Let's ignore the f string for now, I will discuss that a little bit later. And now I'm going to do a greeter too, but it's not gonna be John, it's gonna be Thomas, because he's our newest follower, so he gets the next greeting. And then it will have a very different printout. You can see that the behavior of the greet function is exactly the same. It's just returning the string, but the data it is working with is different because it's a different instance, okay? That's the point of objects on our level, that each of them has the same behavior, but with different data. As you might have observed, Python consists of py files, that is files with the extension py. And each of them is called a module, okay? So right now I have this module called object basics, okay? But the way we typically use objects is a little bit more complex than that, because there is a very strong principle in software development, which is reusability. The point is, when you are creating your classes, and nowadays programming is pretty much creating classes, you have to be very specific on what exactly is the class's responsibility. It should have only one. And you should write it with the mindset that maybe it can be used in other projects as well. And in order for that to happen, we typically put them into different modules. So very likely one module is responsible for storing one object. It's not a hard rule. Sometimes it has many objects, of course, but this is what we are striving for, okay? So what I'm gonna do right now is I'm gonna create a new file, and I'm gonna call this greeter, okay? Greeter.py. And in my Hungarian streams, I always crack stupid dad jokes, so let's start now. We are going to write a greater greeter than we did before. Okay, so here in the greeter, I'm gonna have a greeter. You thought I can do it in English, didn't you? Admit it, admit it. Okay, it will get the name, but it will be much greater. And now you can clearly see that there are lines in all of our Python files that we have written before that have no indentation. They just begin at the very first position, and those are executed. So that's the output that we're typically seeing. But this module is going to be different. Here, we don't need those lines. All this module has to do is store our class, okay? It doesn't do anything, okay? Brilliant. And the greeter will say something like great greetings to you, oh Nobble Hubble. Hubble is not Hubble is a different thing. That's a space telescope. Okay, there you go. This is our module that contains the greeter class. Okay, and watch what I'm gonna do next. I would need in my demonstration, I would need to show the difference between the greeter, which is here, and the greeter, okay? And for this, I need to suck this new class into my module, which I am running. And for this, I'm going to need the import keyword, okay? And what I'm gonna do is, it's actually a little bit more complicated than that, because I can go ahead and just import greeter, and then I have imported the entire module. We're gonna stick with that right now. So Aaron gets the greeter, however, Thomas gets the greeter, okay? And you can see that just like I did with the classes, or the instances rather, also the modules get this addressing form of module name dot function name or class name or variable name, whatever else, right? And it's underlined with red. I'm gonna check what this is. It says it has no member greeter, but I swear to God it does. So that's just a linding mistake, and we don't care too much about that. No, actually, it is there. Hold on, what did I do wrong? Greeter. Did I make a typo or something? That's the most typical case. No, I did not. Greeter. Why do we not have that? Okay, what attributes does it have then, if not? Oh, it's a greeter object. Ah, the names. Oh yeah. Okay. Let me rename this variable to greeter1. Yeah. What happened to me, and we are not editing this out from the actual video for the reason that you learned from my mistakes, which is the best way of learning from other people's mistakes. I had this module named greeter, but then I created a variable which was also called greeter, and the last one won. So this greeter referred to the instance of the greeter class and not the greeter module. So I had to rename it to greeter1, and ta-da! Now we can give a proper greeting to Nobble Thomas here on the chat, okay? So that's how it works. In order to address a module, I will use the exact same dot notation to have functions, classes, and variables available to me in another module. Why is this so important that I'm talking about this so long? The reason is that the way we develop Python is we do a whole lot of packages that contain typically objects, and then we are instantiating those objects in our code, importing them, of course, to our module, instantiating them, and calling their functions, okay? And all these packages that contain the classes that do certain things, they are packaged with a system called pip, P-I-P. Pip, I'm not sure what that abbreviates, is Package Installer for Python, okay? This is pip. And there is a page called pyp.org. It's a central repository, so anybody installing stuff from a pip package will automatically come to this page and download from here. You don't have to do anything. As soon as you have pip installed, you're good to go. Pip knows where to go and knows what to do. You don't have to worry about anything, okay? So the idea that I had right now is to print the greeter greeting in color, okay? Not just in like normal plain letters as the normal greeting, but the greeter will print everything with colors. But I am not sure how to do that, so watch what happens next. I have two options. The first one is I can press Control I and I can remove my face from out of the way and just go ahead and say Python. No, I wanna add the greeter.py. So here you actually have to add the files that you want to work with. And in my case, it's why is it not available? Greeter. Yeah, here it is, greeter.py, okay? I have added this. I have told the AI that I need changes in this file. I need to add colorful printing of the greeting message in the greet function. Obviously, I could just say, make it colorful or something like this. But in my experience, the more precise you are, the better results you would very likely have, okay? Awesome. And now it has a suggestion. I literally have no idea if this will work or not, but I'm not afraid. I just accept the changes, and if it doesn't work, I can anytime go ahead and roll the whole thing back and just undo the changes, yeah? Okay, and now it says green and yellow and green and resetting back everything to normal. I don't know what these are. I don't care, really. I absolutely am not interested. What I'm gonna do is, and now I need to be mindful because I almost pushed the play button, but this module contains no runnable code, right? It only contains the class. I need to go back to object basics and call this one because this is the one. Look at this now. The text is green and the name of Thomas is yellow. So yeah, absolute. A round of applause for Python for coloring our message. There we go. What I'm gonna enhance my greeting with is the time, okay? So we're gonna have a nice message that contains the time. But in order to figure out what time it is, I'm going to need a specific package, and that's what I'm gonna use to show you how packages are used. The time is, and then this thing, never mind about this for the moment. It's a function inside the module that needs an incoming parameter for the format of the time, and obviously it's hours, minute, and second, and returns the time in that specific format. However, note that this module has not been imported yet. We have no time whatsoever, and if I save now, deliberately, so that I can show you what happens, and I go to problems, then it says, undefined variable time. Dude, what's time? You never told Python what time is. Of course, you could expect it to know by heart, but what happens is you go back to the beginning and now you can say import time. Ta-da! The message is gone. Now everything is just fine. Disregard the other error messages. Those are not relevant for us now. And watch what happens if I run this now. Note that the original program never changed. It just calls the greeter and the greet function. We have not touched it with a pinky even, because we don't have to. We are just modifying the behavior of the object underlying it. And ta-da, the time is, this is the time in my time zone right now, at the time of recording of this video. So the point is, this is how you typically use functions that are provided to you by Python or by third parties or by whoever else. In our case, we were using the time as an example. Let me show you the sheer quantity of packages that you can list of pip packages, okay? Pip list, here you go. This is the list of installed packages, absolutely not what we want to have, sorry. The Python package index, yeah, here we go. We have over 600,000 projects with almost 6.5 million releases. But the releases we don't really care about. All we care about is the projects. Like, oh my God, okay? This is an incredible amount. It's even hard to search them. Let me just show you what browsing does. The categories are here, and then you can go ahead and drill down deep. We have packages for Windows 95. What are those? Let me just look. Informix DB, Piper for no idea what these are really. The point is the amount, the quantity of oh, Vamu, I remember that. I used that. Yeah, that was a manager for Nokia phones that was capable of reading the SMS from the SIM card a long time ago. So the sheer quantity of packages is so big that it's essentially almost impossible to find the the packages by random. So the way we typically do this is we look for a problem, and then either the AI or Stack Overflow or ChatGPT or whoever else suggests something for us that is actually useful. Okay. Oh, I still have curses and Windows 95 enabled. That is not possible. Curses is absolutely a Linux thing. Let me remove that. Yeah. Flame show. Okay, you know what? Let's see what flame show does. And this is what a pip page looks like. Typically, you get source code somewhere. Yeah. Download files. You should have a source code or project homepage. Yeah, project homepage. There you go. And then you can see that it lives on GitHub. Most of these projects live on GitHub, so that's nothing new. And here is what it does. Oh, look, it really looks nice. Not very useful for our purposes, but yeah, flame graphs, okay. Okay, so that's the way you don't ever install pip packages. The way you do that is you have a problem, you search for that problem, and then somebody suggests a package, okay? That's how you end up having packages on your system. Let me show you one package that is super important, and I'm gonna show it to you in a terminal, okay? Okay, I think I have a Python tutorial. Yeah, here we go. And what I'm going to do is I'm going to create a demo here, just because why not? Entering it. This package, so here is one problem. When you start installing packages with pip, you saw that there are many packages, plus many of these packages have dependencies, so they tend to install even more packages, and then you end up not knowing anymore what's on your system. Even worse than that, the packages not only have dependencies for other packages, the existence of them, but for specific versions. So for example, package A requires package B to be newer than 4.0. And then sadly, it happens sometimes that you have two different projects. One needs package A, the other one needs package X. Package A needs a certain package D to be newer than 4.0, but package X needs it to be older than 3.0, and then you have a contradiction in your requirements, and you are stuck in the middle of nowhere. In order to avoid that, there is a way to not install your pip packages system-wide. By default, if you install a package with pip, it's for everybody, okay? But there is a way to avoid that, and that is called a virtual environment. I'm gonna show the manual way of creating a virtual environment, and then I'm gonna show you the most comfortable automated way, just so you have an idea. So, in order to do that, we need a module in Python, which is called venv, obviously short for virtual environment. And the way to do it, the way to run a module in Python, now we have discussed what a module is, right? This is a module. And we have also agreed that in this module, all we store is the class. We are not putting instructions here, contrary to this module where we do have instructions, which means lines that begin in the very first column, and so they get executed when that module is loaded. And there are modules that have instructions, some others do not have. And there is this module that you can invoke with -m, sorry, and it's called venv for virtual environment. And this one does have instructions by default, which create a new virtual environment. And all I need to say is which folder should be used to put the files in there. So typically these begin with .venv. The dot means make it a system directory. Don't let anybody see it. Don't bother too much with it. It's just there for the system. And I personally, many people just say .venv, but I have many projects doing a whole lot of things. Therefore, if I would just have venv, I would never know which venv I am in. So I typically add the name of the project to it, venv demo. Ha ha ha, very funny. I don't have Python installed. How is that even possible? Python 3. There was, just so you understand, there was a time when Python had two versions alive, version 2 and version 3. Version 2 is now dead, it's buried, it's never gonna come back, so now we only have Python 3. But due to historical reasons, we still need to say Python 3 when we mean Python on older systems. Yes, Anaconda is another option for sure. Okay. Nothing happened yet. I'm gonna do some black magic here that you really don't have to care about. And watch what happened. I have now entered this virtual environment. So anything I do, any package I install with pip gets installed into this specific virtual environment. So if I say pip install OpenAI here, my big system will be unaffected, but you can see that it installs a whole lot of packages, not just OpenAI. It installed a couple of them, like, I don't know, a dozen maybe or something, yeah? And this is perfectly fine. If I open a new terminal window, you can see that this is gone and I have absolutely not touched this part of the system, only the one that is inside the virtual environment. Anytime I can do the same black magic trick and just load this virtual environment again, okay? This is the manual way that is specific for Linux. You might not want to use it, but I thought you might want to see how easy it is. However, in Cursor, you have a command palette, and there is Python create environment. And if you click that, it offers you two different versions, venv and conda. I personally prefer VM, so I'm going to use that. Conda is equally good, but I'm just not experienced with it, so I will go ahead and use venv. I have two Python interpreters on my system, which is not true. It's the same thing. Never mind. You just need to choose whichever Python is the newest on your own system, okay? And then here is, we are going to skip this for now, okay? And now immediately you can see that a .env has been created for me. That's the folder where my virtual environment lives. And if I come here, allegedly, we will be in the venv, the virtual environment. We are not, but we should be. Trust me that you will be in your own virtual environment. And now here in the terminal part of the bottom screen, if you don't see this, you need to click here, okay? That's how you can make this window appear and disappear. And then here you are in the terminal, and then you can do pip install for whatever package you need in your own project, okay? So that's the way that works. And this was a huge step in your Python learning, because now you can choose utilities, tools that other people have created for you. You can stand on the shoulders of giants and you can create your own projects and be happy with your life. Thank you very much for watching. I hope you learned something interesting about Python classes and instances, and I'm looking forward to see you in the next one.